Hello there, AV here. Welcome to my water-cooled review in the Fractal Design Node 804. If you'd like to check out the previous video, which was an air-cooled system in this case, then check the top right-hand corner. I hope you enjoyed the video. If you do, like. If you don't, dislike. And make sure you comment to let me know where I'm going wrong and where I'm going right, so I can get rid of the stuff that's bad and retain the stuff that's good. I hope you enjoyed the video, and I'll catch you in a second for commentary. Okay, before starting our build, made in China. Anyway, top tip for starting any heavy system build is to put it on a mat so you can slide it around. You're welcome. As always, the best place to start with any build is to get rid of all the case panels at the start. This will give you the best accessibility at all times, and it will make sure that you get the best angle on some tricky situations you may encounter. The front panel of this case is difficult to work with, since the front I/O and LEDs aren't exactly removable. Although you can remove the front PCB, the power and hard disk drive LEDs are hot glued in place. They do look sort of removable, but the hot glue gloops over the sides of the bracket, which doesn't fill me with confidence. So you're really better off finding another less convenient way, which turns out in this case is disconnecting all the front I/O from the motherboard and uncable managing it all from before. It's great that the hard disk drives can just disconnect, and they were only a couple of mechanical fixings away from making this panel flawless, but keep in mind how likely you are to remove the front panel, and if you're anyone like me, that will be on a rare occasion. Now all the front panels are out of the way, it's time to get rid of anything that will get in the way of water cooling parts and anything associated with the previous air cooling. The 3.5-inch hard disk drive sled and the 3 rails will be the first to go. These need removing before any top-mounted fans or radiators can be installed in this compartment. What's annoying is that you need to remove 2 of the 3 rails for one hard disk drive sled to be installed, and this predicates you on having the center rail in place, which stops you from being able to install a single fan or radiator on one side with a hard disk drive sled adjacent. It would have been nice to be able to mix and match between fans and hard disk drive sleds, but you can't have it all. But remember, you can install one hard disk drive sled at the bottom, but that will interfere with cable management. We're also getting rid of the top 2 140mm fans from the air-cooled build to make way for one of the 2 240mm radiators with its fans. And the final fan to go is the stock 120mm fan that came with the case, since it doesn't perform well enough for what we're going for. To make way for the water-cooled GTX 1070, the R9390X can step aside. Like with most cases, 2 screws need removing from the back, and the latch to the back of the PCI Express slot needs to be depressed to release the card. Another small tip, since the air cooler is quite large on this system, I find it helps to use a plastic ruler to push down the latch. Now moving on to the CPU cooler. I may as well mention now that I'm strongly looking into doing CPU cooler reviews, which was suggested to me by a subscriber, so if you fancy seeing any of that, then stick around, and I'll gratefully take any suggestions in the comments section. The ruler comes in handy again to gently pry the fan bracket clips away from the fins, which can be rather sharp. Nearly every time I do this, I forget that one of the taller RAM sticks needs removing, so the far side fan can also be removed. I'm sure giving it a knock each time will kill it eventually, but RAM is resilient, which I'm pretty grateful for. Once the fans are out of the way, the CPU cooler can be unscrewed from its mounting bolts. As always, unscrew all the screws at an even rate to keep the pressure nice and even across the CPU socket. It's always worth giving the heat spreader a wipe down, and if the thermal paste has been on for a while, giving it a spray with some electronics cleaner may be necessary. Then the rear nuts keeping the backplate on can be removed, but here's a super special be careful how the nuts come away from the bolts. The magnetism of the screwdriver I was using seemed to create some weird magnetic field when combined with a hex bolt tooltip. Coincidentally, the nut most in focus represents why this can be an issue. The nut was repelled away from the screwdriver bit and was guided through the grill of the power supply unit below. I'm no expert on power supply units, but that could have turned out really badly, so it's worth covering the grill of the power supply unit during installation and disassembly. Luckily, I was able to turn over the case and it fell out just as easily as it fell in, without touching any components holding any charge. While we're at the back of the motherboard, it's a timely point to install the EK Supremacy CPU water block. This starts with a rubber gasket and a steel backplate, which are held into the motherboard with 4 bolts and nuts. The bolts in question are double-sided and pair up as the hold-down mechanism for the water block. It's easier to sort out the thermal paste and final installation of the water block when the motherboard is laid down. After putting what can be described as some thermal paste on the CPU, the water block can then be lowered on top. Then the 4 pressure balancing springs can be placed onto the bolts, and the 4 thumb screws can be secured on top. Again, being sure to screw them down in an even pattern to keep a nice and even pressure across the CPU socket. Onto the radiators, which are generally the most difficult components to work with. The combination of fan position, where the various screws go, and where it goes within the case can be difficult to work out. And working out where the inlets and outlets will go doesn't help. I recommend buying the case in advance and even building an air-cooled system in it before purchasing water cooling components. This will likely answer most of your questions about your water cool build. So the setup I'm going for is 2 top-mounted radiators, drawing the air in through the front and the back of the case and exhausting it through the top. The radiators are going on the bottom of this configuration, since installing fittings is far easier this way, and the inlets and outlets will be at the front of the case so they can be linked together through the largest front hole between the 2 compartments. So for this to work, the fans were screwed down into the radiators with the smaller screws that come with the radiators, and the fans will be secured to the top of the chassis that will suspend the unit as a whole. There were a couple of radiator holes on both units where I couldn't get the small screws through the fan's frame into the radiator, but this can be turned into an advantage as you can secure the radiator through the fan with the included long screws, effectively making both the radiator and fans responsible for supporting themselves. With the radiators in place, we can finish off the rest of the cooling component installation by fixing the rest of the fans in their pre-designated positions. Due to the radiator in the power supply unit compartment area being a few millimeters further back than the radiator in the motherboard compartment, I wasn't able to install the rear fan here. It could have worked if the top radiator and fans were swapped around, but it's not that big a deal. So both fans in this compartment will be going at the front, and the other compartment is having a lower front fan and a rear fan that will support the pump and will slightly assist with supplying air to the CPU power phases on the motherboard. So, tubing and fittings. Depending on the positions of your runs, it sometimes makes sense to create certain sections outside of the case. It's extremely useful to get your hands on rotary angle fittings for ease of installation. I'd even go as far as getting a couple of rotary straight fittings depending on your build, since some areas can be difficult to align, especially around drain ports and fill ports if you have any. The connection between the CPU block and the rear radiator was the most difficult to align and make look half decent with soft tubing. This run is where hard tubing would come into its own. The far radiator will be supporting the junction between the main loop and the drain port. This is out of sight, which is always preferred in my loops, unless it can be incorporated as a theme. To bring the loop forward, a section of tubing was made up, and a female-to-female extender was needed to connect to it, since it doesn't terminate at a block. If you're new to this, be sure to map out all the components you'll need before purchasing them, and buy extra fittings, since things don't always go as expected. Because the shorter length of tubing was an offcut, I had to recreate that section to extend it. For now it's being supported by a twist tie, but I'll swap that out for a zip tie later. Now for the pump and reservoir. For a solid look, I always try and fit in the larger reservoir. It starts off with mounting the pump in its brackets to the rear fan. Orientation is crucial here, so be sure to work out exactly where it's going and how it's going in first. It's probably a little easier to install these bolts through from the other side if you find this approach a little tricky, but it looks nicer this way round, so that's what I'm going to stick to. The whole unit can be mounted to the chassis by 4 fan screws, which is raising a few concerns for me lately since fan screws are self-tapping, and it doesn't take a lot to shear the plastic thread of a fan with multiple installations. I may need to find a better solution for this in future builds. Threading the reservoir cables through to the other side was probably the most difficult part of this process. The 4-pin Molex plug is very difficult to get through the top cable management hole, especially since it was covered by the radiator unit up top. But with the cables in place, the reservoir could slide in pretty easily. Notice the orientation of the pump bracket has the connecting plate against the motherboard. It's far from touching the motherboard, which isn't an issue, but it will make the connection to the CPU block a little more cluttered. Due to the angled legs on this bracket, this was the only orientation that would both look good, but more importantly, fit in. Even though it was in place, that was only a temporary fit to guarantee the ports between the pump and CPU block would align. Knowing that the connection between the two was possible meant that I could dismount the pump unit, set up again the pre-constructed run, and remount the pump unit. Only this time the pump unit needed to be in the right position for mounting while slotting it into the tubing run. This is where you need to guarantee the fittings are well connected to the blocks and the tubing ends are stretched to ease the fitting. Since twisting the tubing in would not only be difficult, it could also very slightly unscrew a fitting from the block and cause a leak, and this would be the most catastrophic place for a leak to occur. FYI, you could uninstall the reservoir tube to make this fitting easier to reach if you're struggling to get a good angle on it. Luckily this was a one-time process, so no need for any reruns of this section, and I'm pretty stoked on how it turned out. Now for the GPU, which is in my opinion the second most difficult installation due to the connection to the pump above, far from the installation ease of an air-cooled card. With the GPU in place, this is one of those points in a build where plans and reality disagree. For this compact and complicated connection, you'll likely be unable to find the right set of fittings and tubing without physically mixing and matching components in situ. With several different configuration attempts, the link was possible with a total of 4 angle adapters and a 5mm extender at a total cost of over £20. If this sort of connection was a regular occurrence, you can grasp how the cost of a project like this can run away with itself. The final connection from the GPU up to the radiator could have been done in several ways, but I wanted to keep with the style of the rest of the build so far, so I opted for a T-splitter connected by 2 straight runs of tubing. This begs the question, with all these straight runs, why not use hard tubing instead? Well, it's not down to the cost. If you're embarking on this journey, then an extra £5 or so for more expensive tubing and £1 or so extra for each fitting isn't really going to hurt that much, keeping in mind the total cost. It really comes down to the ease of construction. You'll notice that the vertical tubing on that last run needed to travel up at a slight angle to the top radiator, which is easy enough with soft tubing, but would be far more difficult to pull off with hard tubing. Now onto the finale. Tilting the case onto its back gains direct access to the top of the reservoir. If you can, it's easier to fill a system by directly feeding the pump with the liquid rather than through an indirect fill port. It makes no difference if the reservoir is lower than the rest of the loop, since D5 and DDC pumps commonly on the market have the head pressure to push the liquid up to the high regions. Just make sure the pump doesn't run dry during the filling process and don't spill anything over the rest of the system. A length of tubing leading to a funnel for pouring should help you out there. With the filling completed, there is only a little tidying up left to sort out. I replaced the supporting twist tie with a zip tie, and you can get a decent view of the drain port ready for when this system will be dismantled a day or so after upload. The front panel and I/O wasn't too difficult to cable manage back in, since I spent a little time sorting out the cable management to make this process a little simpler. And as before, the hard disk drives needed reconnecting and the panel could snap back on. I think my biggest gripe about this case is the front fan filters. The replacement procedure is a little crude, especially considering there is no well-designed way to lift this thing, and that's a little annoying when it weighs in at 15 kilos or 33 pounds. The top panel, however, went on just as easily as it came off, and the 2 side panels followed the same trend. So just before we jump into checking out the final build, let's take a quick look at the thermal results. With the testing parameters shown at the top, the CPU averaged a respectable 72 degrees, and the GPU ended its test at a cool 48 degrees. To clarify, the temperatures had flatlined minutes before the test was over, so we can assume the loop was as hot as it was going to get. But those results mean nothing without comparison, so over to the comparison chart. This shows the current cases tested so far under the same parameters, and you can check out their videos in the playlist up top. You can see that taking the ambient temperatures into account, the Node 804 is only just cooler than the competition. It seems that throwing dual radiators into pretty much any case is going to yield similar results, but we'll keep testing this to see if this changes. Enjoy some footage of the final build, and I'll catch you afterwards for some closing thoughts. So, final thoughts. This case is built to pretty much catch anything you can throw at it. You could go for an extreme water cooling build far more complex than this, you could build a heavy editing rig and couple that with an extreme 8-drive RAID array. Or you could even use this as a ground level case for a small growing business with plenty of room for growth. But this video is really here for you to be able to make your own mind up about the case, but if you have any more questions, please feel free to sound them off in the comments below, and I'll do my best to answer them as thoroughly as I can. And finally, thank you so much to, well, you guys for watching. We've actually been able to push this channel to a point of a paycheck. Okay, granted, I earned more washing cars through a weekend years back, but it's a milestone and hopefully one of many. Finally, for those of you gracious enough to stick around to the end, the next video will be some sort of system build in the Thermaltake Core P3. This will be the contender for my open test bench for future testing like CPU cooler reviews mentioned earlier. So that's it, thanks again for watching the video and I'll catch you in the next one.